Precalculus student, this video is for chapter 5.2 still. Unit circle. In the last video, we talked about how we can make a unit circle, which is kind of like a function machine. So if you want to find sine and cosine of anything, what you do is you look at those terminal points. I call it terminal points because it's the point the terminal side of an angle intercept with the unit circle. And by definition, the x coordinate of that point of intersection is cosine of this angle, right? Whatever that the terminal side ends, cosine of that angle. And then the y coordinate is sine of that angle. So for example, this is angle 30, because if I go from the x-axis up as positive 30 degree or sine or pi over 6, then cosine 30 degree is with 3 over 2. Sine 30 degree would be 1/2. Cosine pi over 6 is with 3 over 2. Sine pi over 6 is 1/2. So you can read off them in the unit circle. This is a complete unit circle. I did it with in the last video by splitting them into two parts. The first part, I complete the unit circle of the corantal angle and the 45-degree angles. And the second one, I complete the 30-degree and 60-degree related angles. But this is the completed one. I have a copy of the completed unit circle on Canvas right here, so you can study it and then or use it. But eventually you should memorize it, or at least if you don't memorize it, you should know how to create it. Okay, so if I give you a blank unit circle, can you from scratch write all the degree, write all the radian, and also write all the coordinate? Because it's not like we have to memorize them, because you can refer to them during tests and during online classes. But if you know the relative position, or you kind of know what is special angle, it helps in your next the course, Math 187, to actually solve a trig equation. If you always have to look, or you don't really understand how the numbers are related, then it's kind of difficult. So spend some time to get yourself familiarized with completing a unit circle within 5 minutes, without looking, of course, complete it yourself, or be able to, know the relative position. If someone call out a number, you know where they are. Okay, so we will use the class worksheet for you to complete once. Maybe you can figure out how long it would take you. And then we will also have a lot of this question, like kind of drill question, to drill you into get yourself familiarized with the values of those numbers. One way to do this, or there's 3 facts that you would know. First is you have to memorize the first quadrant, like 30 degree, 45, and 60. If you don't remember the, well, actually what you can remember is for 45 is always root 2 over 2, root 2 over 2. And then for the 60 and 30, they switch, right? For 30, it begins with root 3 over 2, and then the second number is 1/2. But for 60 degree, which is pi over 3, is 1/2 root 3 over 2. And then once you do that, then the other one, kind of like a reflection of them. You have to know that they are related to certain angles. So 30 degree is related to 330, 210, and 150. Why? Because they are as a result of 360 minus 30, 180 minus 30, and 180 add 30, etc., etc. So know how they are related. Okay. If you want to, there is a those unit circle game that you can play online to get yourself. Do I have one? Let me see if I can open unit circle online game. I'm sure there's something like that you can play on your phone also. Oh, yeah, this purpose game. I don't know if it's available on the phone. So they would have all this blank, and they would you press play, and they would call out a number like 90 degree. Where is it? Okay, I know it is. I click on it. Okay, negative 1/2 and negative root 3 over 2. Where should it be? Well, I think it is negative, negative, so it's one of these, but I think negative 1/2 will be this one. Yeah, like that. Okay, the time you, don't worry about the time, but make sure that you just have some tools to get yourself familiarized with the unit circle. So let's try to use these to evaluate sine and cosine. So remember, sine and cosine, if you give me an angle as the input, um, there's no formula. There's no formula. Basically, you would use the unit circle to read off the answer. So what is cosine pi over 6? I would usually draw it and I would say, okay, pi over 6 is here. And this point is, I know is root 3 over 2, comma 1/2, right? Pi over 6. And so cosine is this, so that's equal to root 3 over 2. So in your worksheet, I want you to do it this way. It give you a chance to, okay, pi over 4 is the 45 degree. This number is root 2 over 2. The terminal point is root 2 over 2, root 2 over 2. Sine is the y of it, so that is equal to root 2 over 2. Sine pi over 2, that's really easy because it's the 40 and the 90 degree. This point is 0, comma 1. So sine pi over 2, that's pi over 2, right? So it will equal to 1 because it's a y coordinate. Cosine 3 pi over 4. So cosine 3 pi over 4 is here, so you draw the angle. This point is 0, comma negative 1, but cosine is the x coordinate, so I say it's equal to 0. So just give yourself a chance every time you evaluate something, we draw the part of the unit circle that helps you to find it. Let's do sine 4 pi over 3. Where is 4 pi over 3? It's 4 pi over 3 is 3 pi over 3 plus 1 pi over 3. You can think of it as is actually pi plus pi over 3. So it's on the third quadrant here, right? 4 pi over 3. And yeah. And then what is this numbers? Negative 1/2, negative root 3 over 2. Because you can think of it as putting the triangle here is negative 1/2, negative 3 over 2. Sine is this one. Sine is the y coordinate, so it's negative root 3 over 2. You read off from it. Cosine 11 pi over 6, do you know where cosine 11 pi over 6 is? It's actually 2 pi. Remember, the result is 2 pi minus pi over 6, so it's in the fourth quadrant over here where my pi over 6 is here. So it's really similar to pi over 6, right? Except for the y coordinate. So it's root 3 over 2 negative 1/2 because I know pi over 6 is root 3 over 2 1/2. So I want cosine, which is this one. So I'll say cosine 11 pi over 6 is equal to root 3 over 2. Okay. What about 7 pi over 4? Where is 7 pi over 4? It's also on the fourth quadrant. How come? Because it's 2 pi minus pi over 4, right? This is pi over 4. It is, and here is 2 pi. You go back pi over 4, it will be 7 pi over 4. So this is the angle. What coordinate do I have? Whenever it's pi over 4 related to 45, it's related to root 2 over 2, right? But the y is negative, negative root 2 over 2. So I want sine. Sine is this number. So this is sine. Oh, I go sine root sine of 7 pi over 4. So I would say this is negative root 2 over 2. Okay. The input and the output. So never write sine root 2 over 2. So knowing the radian input is more important than knowing the angles because the real in calculus, when you use the sine and cosine function, we never use degree anymore. We use radian. Okay, but it's good to know these also. What is cosine 240? Do you know where 240 is? 240 is 180 at 60, right? It's here. Oh, it's the same as this one. It's negative 1/2. Root 3 over 2 negative, and I want cosine, so there's negative 1/2. 300 is where? Is this one, right? Because it's 300 minus 60. So again, it's similar to the 60. You can write out the 60 first. The 60 is 1/2 with 3 over 2. So 300 minus 60 would still be 1/2, but the y is negative. It's negative with 3 over 2, right? So then I want sine. Sine is negative with 3 over 2. So you would say this one is equal to negative with 3 over 2. Cosine 135. I would draw 135. I know it is here because it's just 180. I actually have to know that 1 is 180 minus 45. So it's right here. And this point is root 2 over 2. No, negative x, positive root 2 over 2. And I want cosine. Cosine is negative root 2 over 2. So this is the 3 answer for part B, which is angles that are in a degree. So example 4, find both sine and cosine of 13 pi over 3. I don't have 13 pi over 3 in my unit circle. How do I do it? 13 pi over 3 is actually more than 2 pi. So I'm going to subtract 2 pi. What would it be? Be minus 6 pi over 3. That's 7 pi over 3, right? Is it good enough? No, 7 pi over 3 is still not. So minus 2 pi again. So that would be minus 6 pi. 7 pi over 3 minus 6 pi over 3. That is 1 pi over 3. So although it is 13 pi over 3, the way I draw it is the same as pi over 3. You can do it multiple times, but I don't. Okay, so with this way, right? But it is the same as pi over 3. So what is the 2 coordinate? It's 1/2 with 3 over 2. So you would say cosine 13 pi over 3 is 1/2. Sine 13 pi over 3 is root 2 over 2, with 3 over 2. You can see that the periodicity of these two functions. When we do pi over 3, it is the same thing. When we do 13 pi over 3, it's the same thing. So it repeats. What about negative 3 pi over 4? So this is not in the unit circle from between 0 to 2 pi, but I kind of know if I graph it, it's right here. So it's the same as 5 pi over 4, right? It's the same position as 5 pi over 4. If you don't know, you can think of it as negative 3 pi over 4 plus 2 pi, and you would see that it is actually 5 pi over 4. This one is negative root 2 over 2, negative root 2 over 2. So I write down negative root 2 over 2, negative root 2 over 2 is coterminal at 5 pi over 4. So I would write sine of that, negative 3 pi over 4 is negative root 2 over 2, and cosine of negative 3 pi over 4 is very messy, not enough space. It's also negative root 2 over 2. Right. So if there's angles that is not within 0 to 2 pi, you just do the coterminal angle. Add 2 pi, subtract 2 pi until you have the position in the unit circle from 0 to 2 pi, and you can get it. So the next one is to do a calculator. So these are special angle, you need to use those in the unit circle. But if they are not, then you use calculators. And so the way we would do it is use decimal. Now, you can do decimal if you are doing a radian, like pi over 7, right? So these are all radian, but you cannot do degree. So for degree, you would need to use another one called, let's do another decimal scientific. Scientific calculator decimal, so they would have, so there is no graph, it's just decimal calculator. So you see how they have degrees. So by default, if you do sine 30, it would be 1/2. Oh no, sine 30 is 1/2, right? It's 1/2. And because it's in degree, if you do radian, you would do it this way. So it also has tangent and everything. So if I do cosine 18, maybe I'll do it in the next video because I don't think I have time to finish this. And then in the next video, we also will talk about how to evaluate other trig function using the unit circle.